All right, guys, welcome. All right, so join us. Let me get my mic. All right, welcome. Good evening. So please, if you can hear my voice, could you just tap on the like button? If you can hear what I'm saying. Yes, we are just starting. Sorry. Yes, we're just starting. The class was scheduled for 9 p.m. Yes, this is the second experiment. But I already taught this. The video is already live. I made this video on Sunday, so this is not what I'm teaching today. All right. So guys, like I said, welcome to today's class, our on live class on Chem 130. Okay, let the board dry. So please, can you hear me? If you can hear me, just drop it on the chat box. Let me be very certain. This is a live class on YouTube, so you guys are not allowed to speak. So I will teach, and then for some minutes, I'll come and check the chat box just in case there is any question. So if you have any question you would love to ask, please just drop it on the chat box. All right. Once I'm done explaining a particular topic, I'll come straight away to check it out and give us feedback. Okay. So, okay. All right. Thank you. All right. I can hear you, sir. Basi Bright, thank you for that. And everyone that has commented, yeah, blessing Amoyin. All right. Okay. So I would like to ask, what were you guys taught today in Chem 130 in class? Because I learned you guys had Chem 130 today. So I would like to know, if you don't mind, could you just drop on the chat box what you guys learned today? Because I actually want to introduce a new topic, so I will need I'll treat that topic. Right? I just want to make sure that at least you guys will actually be following with your lectures. So whatever they taught you guys today, drop it. If it's a topic that makes sense, that that will not make us feel sleepy, I'll treat it. But if it's not something that is really very tough for now, I'll leave it. Maybe much later we can always do it. I'll come back to that. So far, for those persons that are just resuming, in physical class, we've covered a lot in physical class from last year. All right, but you don't have to worry yourself. All of the things we've covered, There are videos for them in case you choose to watch the videos. There's also going to be a live a physical class all over again. So whichever of them you want, the videos will be made available to you, right? And also the physical class. All right. Now, an interesting topic I would like to teach today is periodic table. Periodic table happens to be so today's class we're going to be looking at periodic table. Okay, periodic table happens to be one of the toughest. I call it one of the most logical topic in chemistry. But today I'll be breaking it down in such a way that everybody is going to understand. So first thing first, we're going to be looking at what the definition of periodic table is. We're going to look at the definition of periodic table, all right? What periodic table is all about. And after that, we look at characterization. Now, before I continue, I'll put it to you guys that majority of us that did periodic table in secondary school did not really understand it. You crammed it. And that is why you see a lot of students failing periodic table questions here in the university because they never understood it from secondary school. So this is a very technical topic. So after characterization of periodic table, we have properties of elements. Now this is where the atomic size, ionization energy, electron affinities, this is where all of them fall into. And after this, we look at what we call isoelectronics. So I'm going to do this. Now, I have two topics on the board. These two topics, they go hand in hand because when we talk about chemical bonding, it's basically the combination of elements to form a compound. So you need this for this, and also this will help you understand this. So I would like us to choose between these two topics for today. Which one would you prefer I start with? Should I start with chemical bond, or should I do chemical bonding this night? Or I should do periodic table this night? Please, whatever your answer is, drop it on the comment. Class, listen. In the next 30 to 40 minutes, I must have covered 80% of this. I don't really need 2 hours to cover a topic. All I just need is your attention. So choose between periodic table and chemical bonding. Okay? Sorry, I've not started. I'm just trying to, allow others to join because once I start, it's a marathon race. So choose between periodic table and chemical bonding. So whichever of them you would like me to teach this night, drop it on the comments. Let me see how many of us are thinking the same way as I do. All right, so class, some persons say periodic table, some say chemical bonding, but now I got you guys. Let's start with periodic table. Now, why am I starting with periodic table is because you need to understand periodic table before we can move down to bonding. What actually is used in bonding is elements. So periodic table is going to really help us understand elements, right? Because it is element that we need to understand bonding. So if I should jump to chemical bonding without treating periodic table, yes, it's possible for you to understand it, but it would be better I laid the foundation here before moving on to this next one. So thank you very much for everyone that contributed. So let's start. So please put down, periodic table is a table that shows periodic table is a table that shows the arrangement of elements, or some persons could call it atom, right? They show the arrangement of elements in order of increasing energy. Now, what you did in secondary school was basically the first 20 elements of the periodic table. But here in the university, we have what we call the modern periodic table, all right? Now, the modern periodic table contains more than 20 elements. So if you could notice that that one they taught you in secondary school was just an extraction of 20 elements from the entire table. So I'm not necessarily going to give us a full table, right? But let me just give you a clue of how the full table looks like. Looks like this. All right, so this is basically how the modern periodic table looks like. Now, this first column we have here, this first column is what we call the S block. Now, this one at the center is what we call the D block. And this one here is what we call the P block. Now, there is always two rows of elements at the bottom of the periodic table. We call those ones the F block, or the lanthanide and the actinide, which for the purpose of this class is actually above our outline. So what we have here is the first 30 elements, right? I'm trying to complete this, but some of the elements is skipping my brain. So this is how modern periodic table looks like. Now, what you did in secondary school was just an extraction of the 20 elements, which is 1 from here up to this point. So that was what we did in secondary school. Okay, so we've seen the definition of periodic table, what periodic table is. For every topic I teach, I always make us understand the various ways question can be asked. But before we actually enter the various ways question can be asked, now let's look at the different areas that we need to study. We've seen the definition. We said periodic table is basically a table, right, that shows the arrangement of elements in order of increasing atomic number. Now, please, this is not energy. Please, this is not energy. Increasing atomic number, please. Increasing energy is electronic configuration. Sorry. Please, this is increasing atomic number. If you notice, the first element has atomic number of 1. Now, the second element has atomic number of 2. The third has 3. The fourth has 4. So, the atomic number is increasing. That is why we said, now this guy has atomic number of 13. 14, 15, 16, 17, 18, 19, 20. So that's basically what we mean by increasing atomic number. Okay? So let's look at the next one, characterization of periodic table. Now, when we talk about characterization, as a human being, if somebody asks what is your characteristics, that's basically they are trying to know you more, right? So characteristics of a male is that male have no, I don't want to, like, if they say characteristics, basically what things that makes you outstanding as a man or as a woman. Okay, you understand what I'm trying to say? So in this case now, when we talk about characterization, we are talking about everything involved in this table. What are the roles? What are the periods? What are groups? Right? Because some persons see this as a table. This table houses so much information, a lot of information. With this table, you can tell the blocks of elements, whether element is P block or S block. With this group, you can actually tell if an element is a metal or a non-metal. If somebody asks what are metals, right, you must indirectly always make reference to periodic table, because what we know as metal was originated from periodic table. So if we don't just see it as a normal table, we see it as a table that houses so much information. First thing first, these rows, the rows are the horizontal and the verticals are the periods, sorry, the groups, right? Now, these are the rows, horizontal, column are the verticals. Now, somebody asks you how many rows and how many columns do we have in modern periodic table? Those are characteristics of that table. How many rows? Because if you know the number of rows, that was why I was able to draw this stuff offhand, because I know that this guy has so number of rows and this guy has so number of columns, although I did not complete it because I didn't think it was necessary for now. So the rows and the column, please put down, let's start without wasting so much time. Please put down, modern periodic table has 18 columns and 7 rows. Please, this column is same thing as groups, and the columns are same thing as periods. Now, the column are the vertical, and this guy is horizontal. So when we talk about the period, we are talking about the ones on the horizontal. When we talk about the groups or the columns, we're talking about the ones on the vertical. So one of the characteristics of periodic table is that, number one, it has a modern periodic table, right? What you guys did in secondary school, like I said, that was not periodic table. That was just an extraction of the first 20 elements, all right? And at that point in time, that was what your brain could carry. Okay, so this one is left for advanced, which you are here now. So 18 columns If you count these lines, it's 18. 7. Oh, I don't really know what's wrong with. I think. Okay. So this is what we are going to do. So let's number it. So this is group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now this numbering is according to IOPAC. Periodic table is numbered based on two ways: the IOPAC nomenclature and the American, which we call the CAS. Alright, so for the IOPAC, it numbers periodic table from 1 to 18. For the CAS, which I wouldn't want to dwell on this night to avoid confusion, let's understand this one first. But I just want to talk about CAS. CAS, or the American System of Numbering Periodic Table, divides periodic table into two subgroups. We have the A subgroup and the B subgroup. So, but we are sticking to this IOPAC, all right, because IOPAC numbers periodic table from 1 to 18, which is what we just did here. Now let's look at the second characteristics of periodic table. Number 2. Please pay attention. Period 1. Now this is period 1. This is period 2, period 3, period 4, period 5, period 6, period 7. Periodic table. Modern periodic table has 7 periods. Right? Now periods are basically, a set of, when we say period in periodic table, we're referring to elements that have the same property after you've counted a particular number. Right? Something that occurs repeatedly after a particular number. So if I count 8, we see element that when I count another 8, we see the same element that behaves the same way. Right? So imagine if I see this marker, I count 8, I see another of this black marker, I count 8 again, I see another of this marker. I can group those markers and say, for the fact that each time I count 8, I'll see this same marker. Each time I count 8, so I'll place them in the same period. That means after a particular number of time, I'm seeing the same thing, right? So the period in this case, we are referring to a case where the same thing occurs after a particular period of time. Okay, so period 1 contains 2 elements. So if somebody asks you how many elements is contained in period 1 of the periodic table, it's just 2, which is hydrogen and helium. Hydrogen and helium. Period 2 and period 3 contains 8 elements. 2 and 3 contains 8 elements. Period 4 and 5 contains period 4 contains 18 elements. 4 and 5. Period 6 contains 32. Period 7 is incomplete. Just in case you're wondering how I got to know this offhand, you don't really have to stress. How you got to know the Lord's Prayer offhand? You know those prayers we used to say when we were small? Our Father who art in heaven, hallowed be your name. We actually, with the help of God, right, we understood it over and over again. So with the help of God, I've understood this one through practice. So if you really want to understand anything at all, with the help of God, if you actually, continue practicing, of course, all of this becomes so easy for you. So period 1 contains 2 elements. Period 2 and 3 contains 8 elements. Period 4 and 5 contains 18. 6 contains 32. And 7, period 7 is incomplete. Now, at the end of this class, I'm going to be attaching the periodic table in the video, because hopefully I'll try and edit this video and see if I can attach it. I'll drop it on the comments as well as in our group chats, like the WhatsApp group, so you can quickly scan through it and count. Now, I'll give us an assignment. Please take note of this assignment. Show how periodic table has 32 elements in period 6. Show how periodic table has 32 elements in period 6. That is your question. Okay. All right. So that is the next characterization. Please, if you have any question, drop it on the comments now. All right. I'm about to check the comments so I can attend to questions. All right. I'm checking the comments. I'm seeing somebody saying conservation of mass. Okay, so our next class we're going to treat conservation of mass. It's a very tricky topic that a lot of us did not understand in secondary school. We just skipped it. Yeah, and so that is it. All right, so any question, please? Can I continue? Please, if I can continue, just drop it on the comment. Just say continue. Let me be sure you can hear me. Should I continue? Please, I need to be sure. Okay, okay, thank you. At least you guys can hear me. I was beginning to wonder why you guys cannot respond. All right. This is us testing our online class to see how it will look like. Okay. Now, other characterization that is under periodic table is basically what the groups are called, right? Group names. Now, group 1 elements, group 1 is or are called alkali metals. I'm very certain majority of us from secondary school are aware of this particular topic or this particular stuff. We have alkali metals. Now, group 2, which is this is group 1. Group 2 is alkaline X metal. Now, group 3 is boron family. Group 4 is carbon family. Sorry, please, group 3 is what you guys know as group 13, is what you guys know as group 3 in secondary school. So you need to start, trying to understand. In case they say group 13, you will not be like, what you know as group 3 in secondary school is group 13. Remember, in secondary school, you skipped this 10. This is 10 columns. You skipped it in secondary school. Some secondary schools did it, but some also skipped it. So take note of that. This group 13 is what you guys know as group 3. But then they did not write it as 3. They wrote it as I think Roman numeral. So this is how, take note of this. All right, this is group 5, group 6, group 7, group 8, or 0. So when I say group 13, we are referring to what you know as group 3. When I say group 14, we are referring to what you know as group 4. Now group 5, you can call it nitrogen family, or pnictogens. Group 16, you can call it chalcogens. Group 7, we can call it halogens. Group 8, you can call it noble gases. Noble gases. So that's basically the names of the different groups present in the periodic table. Okay, so the next thing we are going to do now is for us to classify them as metals and non-metals. Remember I said with the help of periodic table, a lot of persons in the past were able to tell which of these metal is, which of these elements is a metal. Now, an element is classified as a metal, not, okay, let me not say is. A periodic table can be used to actually classify elements as metals or non-metals depending on its position on the periodic table. In as much as periodic table can be used to tell if an element is a metal, it is not the only criteria. The major criteria needed for us to know if an element is a metal or a non-metal is to know the properties of that element. Does it donate electron when it comes in contact with another atom? Does it donate electron, or does it accept electron, or does it share electron? What is electrical conductivity? Can it be used as a metal? Your phone you're using today, most of our phones we are using today is made from materials. All right, these materials you're seeing, your phone, your watch, every of these came from this element, right? Not these ones like we are seeing here. If you go down periodic table, right, all those elements you're seeing, tungsten, um, um, zirconium, all of those guys, right, they all have properties that they can harness to convert it to metals. Okay, so let's look at how we can use periodic table to classify elements as metals and non-metals. All right, stay put, please. All right, now for metals, mainly it is group 1, group 2, 3 to 12. Thirteen, except hydrogen and boron. Now, there are exceptions and others. There are exceptions. Now, this is what I mean. If you look at group 1 is a metal except hydrogen. Hydrogen is the first member. So apart from hydrogen, which is a non-metal and is present in group 1, right? The rest of elements in this group are metals. So this guy is a metal, which is group 1. This guy is also a metal, which is group 2. Now, this from here to here, this is called transition metals. So just in case, the D block element, the D block is called the transition metals. So these metals here is not for fancy. So that was why everything from 3 to 8 to 12 was added. Everything here is a metal. All right, that is why I said in materials, right, for them to produce material, they use elements, a lot of it. If you go to the US, United States of America, or some other European countries, you can see how they harness these metals from nature and turn it into something that you wouldn't actually imagine exists. All right, have you ever asked yourself, how do people manufacture the casing for phone? All of these things we are using, where do they source the raw material from? How does it originate? Now, the same way crude oil originates from the earth, God has already given it to us. We just pull it out, harness it, and use it to power our cars and everything. All of these things we are using, our watch, wristwatches, phones, all of these elements are actually natural resources that God has blessed the earth with. So people harness it, refine it, transform it to what me and you we are using today. So just in case you're wondering, all of these things we are learning, why are we learning it? There are so much application in this, all right? Just that you have to enjoy it so you can pass it very well. You cannot frown. And why are we doing this course? No, you don't have to frown. So transition metal from 3 to 12, they are metals. Now in group 13, if you notice, I said except boron. I did not really include boron. Now, is boron a metal? Boron is not really a metal. Boron can actually react with a metal when, in that case, it's acting as a non-metal, or vice versa. It can react with a non-metal. In that case, it's acting as a metal. So boron is not necessarily a metal. I wouldn't really place boron on a metal category. Okay, so boron is more of a non-metal than it is a metal. Take note of that. So at this level, they wouldn't really want to stress it so much, but just know that elements at the left hand of the periodic table or at the center is more of metals. The ones at the far right of the periodic table, right, are non-metal, with the exception of the last column, which is a gas, noble gas. Take note, the left hand side of the periodic table is more of metals. The center of the periodic table is also more of metals. The right hand side of the periodic table is more of non-metals, except the last column, which is this guy. This last column, we don't really call them a non-metal. Okay? Those guys, they have their name. There are noble gases. They don't really react. When we say non-metals, non-metals have properties. For you to say somebody is a boy, it has a property of a boy. So non-metal have properties. One of the properties is that they actually accept elections when they are involved in bonding, but these guys do not. So there are a lot of things I wouldn't like to expatiate in this class. I just want us to know what you need to know, that metals are group 1, group 2, and the rest. Now non-metals are basically, we can place them from 14, which is you guys group 4, to 17, which is you guys group 7. Now silicon, but before I proceed, there's what we call non-metals and there's what we call metals. Fine. You know that if there is hot, extreme hot, and there is extreme cold, there can still be a midpoint where something is not really very hot and something is not really very cold. So if we have metals and we have non-metals, of course there will still be some ones that they are neither metals, they are not full metals, and they are not full non-metals. So depending on the condition, right, they found themselves, they can behave like a metal or they can behave like a non-metals. So Those guys, we call them semi-metals or metalloids. Example of such, I'll place silicon there, I'll place germanium, I'll place antimony. All right. Please don't just take my word for it, also confirm it as well. At the end of this class, please do well to read up at this. I'm actually do us a favor of just dropping a copy of a screenshot of my material, right? If you need something you can read Chem 130 to understand very well, like become so sound in chemistry, I have a material that was written by me, chemistry guide. It breaks down all the topics in your textbook, all the things your lecturer is teaching and all the ones they will teach. It's broken down. If you need a copy of this, you can drop a message, all right, after the class on the group chat. So for those persons that may not necessarily have my number, if you have any inquiry, please also do well to add. So far, we've taken definitions of periodic table. We've done characterizations, all right? We are still under characterization. So now let's look at blocks of elements present in periodic table. Blocks of elements. Now, when we now get to chemical bonding or properties of metals, chemical bonding, yes, we are now going to expatiate. We are now going to throw more light on the properties of this metal, what makes them to be a metal, right? So chemical bonding is more like an application of what is found in the periodic table. Okay, so it's just like, I don't want to, okay, let's not stress this. So take note of what I just said. Now when we get to periodic chemical bonding, we are really going to throw more light on these elements one after the other. Blocks of elements in periodic table. Blocks of elements. Of course, I'm not referring to bricks that they use in building houses. So when we say block, we're not talking about classroom blocks, okay? So we're just talking about, it's still the concept of classroom. Block A, block B, block C. Block A is for JS1, block B is for JS, that's the concept. So the block 1 class is S block. We have 4 blocks of elements in periodic table. Four blocks of elements in periodic table. We have S block, we have P block, we have D block, and we have F block. So those are the 4 blocks of elements. Now the S block are the first 2 columns. I already explained that. And how do you know if an element, let's say for example, you write electronic configuration of an atom. Through electronic configuration, you can tell if this element is S block or P block, right? Just imagine a case whereby people from, let's say, I'm just trying to give us an illustration so you understand it very well. Imagine a case where people from a particular tribe or a particular place in Nigeria, right? They actually they always barb them a particular hairstyle. So once you see them on the road, once you see that hairstyle, oh, you know that this person is actually so it's just like in the university, pharmacy students have their uniform. So once you see somebody wearing white and ash, automatically you say this person is a pharmacy student. So that's the concept I'm trying to make us understand here. Now, S block, first and foremost, let me tell us where we can find the S block in the periodic table. Then I'll go ahead to give us the distinctive features, or how you can tell if an element is under S block based on its electronic configuration. So S block is the first two columns. All right, this first one I'm looking at is the S block. The P block is the sixth columns on the right hand side. S block is a 2 column on the left. P block is a 6 column on the right. D block is a 10 columns at the center. And F block, which I said we don't really need it. It is always the two blocks of element that is lying beneath this table. If you have any question, please drop it on the comments or drop it on the chat box. I'm about to inspect the chat box now, so I can just wrap up this. Remember, this is just a test run of our class, okay? Now, this week or next week, I'm going to create a timetable whereby our class will start by 8 because it's already, past 10 p.m. Subsequently, our class will start much earlier, either 8 o'clock or 8 o'clock, because I believe by then everybody must have gotten back home relaxed. We draft out the timetable, teach it as if we're in lecture hall. If you have any question, please drop it in the chat box. Let me check it out before I come back to complete this. Also, lest I forget, please, if you're watching this video, please tap like button. Just tap the like button so that the algorithm can actually recommend our videos, right? If we are 100 persons in this live video, every one of us should tap the like button. At least it's going to give me 100 likes, right? And before you leave, just drop a comment, okay? It helps YouTube to push our videos and our channel forward. So if you have any question, please drop it. In the meantime, please tap the like button to encourage us to do more videos. Thank you. Okay, please repeat the blocks. Why is period 7 incomplete? Because we have not found elements to complete them. Somebody say God gifts. Please, I would love if you explain that 6 for us. Which 6 are you talking about? Could you be more explicit, please? Which of the 6 are you referring to? Yeah, repeat the blocks. Okay, I'm going to repeat the block. Okay, somebody asked the question and said, why is period 7 incomplete? Period 7 is incomplete because they have not found enough element to fill into that block, right? It's just like, imagine hostel block. They build a very big house and then people did not actually subscribe to accommodation. That place will be empty. So the reason why period 7 is not complete is because they have not found element, which I'll find that element and I'll add it here by next tomorrow. Okay, now let's quickly run through the block. Now we said block of an element basically houses elements of the same, almost the same arrangement. So without so much stress, if somebody should ask you how many blocks of element do we have in periodic table, just like, so let me just leave illustration because there is no time. We have 4 blocks of elements. The X block, which is the first 2 columns. Columns, I mean vertical line, vertical. This is a 2. Remember, it's just that this place now there is no space. I'm supposed to have put a line here. The first 2 columns are the X block. The 6 columns here are the P block. 1, 2, 3, 4, 5, 6. The 10 columns at the center is the D block. F block is always written beneath this table, which I feel is not necessary to add it today. Okay, so now S left hand side, the first 2 columns on the left. P block, the right hand side, the 6 ending columns on the right. D, the center, right? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So take note of that. Now, let me show you something. I want to ask your opinion now, because for me, I always take people's opinion, at heart when I want to do something. Doing this live class or recording a video of each topic one by one, explaining it in details, which would you prefer? A recorded video or a live class? Your answer, listen, is going to shape our online class. If you say more of live classes, we increase the number of live classes and reduce the number of videos. If you say videos, but for me, if you ask me, I would say shoot more videos, students should watch, then we come to live class, we take past questions and we solve past questions. Because live class, no matter how much I want to cover, right, I'll spend more time. But if it's a video recorded session, all those parts I'm making comments not directly, related to what I'm teaching, just to help us understand. In videos, I'll cut it out. Like what these things I'm saying now, if I'm to edit this video, I'll cut it out. But since it's live, it is capturing and it is elongating the time of the video. So me, I'll suggest we do more of videos. I shoot, I post, you watch. We come to live class, we solve questions. If you have any questions, you ask. If you don't want it, we do more of live classes. So please, I would love your opinion, because you guys are the one live here. So whatever decision I'm going to make will be formed or shaped by your opinions. Do you want more of videos and live class for questions, or more of live class and less videos? Please drop it in the box. Please, if you're yet to like our video, please do that. Now let's say example. We have two electronic configuration. Now this is electronic configuration. Majority of us may have seen this. Some persons understand what this stands for, while some other persons do not necessarily understand. I'll break it down. Now this is electronic configuration of an element. So if you look at the number of electrons, say is 2, 2, and 6. That is 10. Electronic configuration is basically we arranging the electrons present in an atom accordingly. If an atom should have 10 electrons, it's just we now arranging it. Okay? So if an atom have 20 electrons, by looking at this, you can tell the total number of electrons present in that particular atom. So these electrons are the numbers written as the superscript. So this is 2 plus 2 plus 2. So whichever atom that has this has 10 electrons, right? Which most likely is helium. This one is 2, 4, 10, 11. Whichever atom that have this have 11 electrons, which most likely is going to be sodium. I'm going to teach us that when we get to electronic configuration, so you don't really have to stress. I wanted to show us how you can use electronic configuration to tell if an element is under the S block or the P block. It's very simple. Pay attention. Once electronic configuration is given, look at the last orbital or the last letter where the last electron entered. So this guy has 10 electrons and the 10 electron is present here. So this is the last orbital. It means that the last electron entered into P. So it means that whichever element that is will be under the P block, which I just told us it was helium, neon rather. This guy has 11 electrons and the last electron entered into this guy, and this guy is S. So you come to this guy, this is sodium. So the last orbital or the last alphabet in electronic configuration determines whether that guy is an S block or P block or D block. Right? It's already past 10 p.m. So I wouldn't want to continue again because a lot of it's beyond normal time to learn. Many of us have not started going for night classes yet. It's during night classes that we can be staying past 10 p.m. And also, my wife is complaining. All right, my wife. I'm just kidding, Jerry. So I'm going to stop here. But if you have any question, please ask. Like I said, I'm trying to actually strategize and make my life, my online classes explosive. Okay, so video, recorded video, or live class, which one do you want more? I already gave you what I feel is best, but if you have any other contrary opinion or view, just drop it on the comment. So I'll stop here for today. I hope you guys like the class. Please make sure you don't leave this class without liking the class. Just you see where there is hand like, you just tap it as like. Okay, thank you. Any question, please drop it on the comments. Okay, so I'm seeing lots of live classes here. Someone said there is no B block. That's the only B. Now A. Please, there is no B block. We have only S, P, and D. There is a reason for that, which I'm still going to tell us. So I'm just taking time to go through this guy. This person said, good work. Amma, thank you very much. Words like this, to encourage us more. All right, so please, this person that asks, why is period 7 incomplete? I'm sure you've gotten your answer. I said it's because they've not found elements to complete it. That is why they just kept it empty, right? Until, okay, I mean period 6. Period 6 basically is 32. Period 6 is 32, which I will show us maybe in the next class. Somebody said 8:30 p.m. will be better. Okay, all your views are very, very valid. So you say 8:30, no problem. I think that's also cool. It gives you guys enough time to settle down, from the day stress, relax, and then have your meal and do whatever you have to do ahead of the class. So thank you very much for joining. Thank you very, very much. I know it's actually quite impromptu, but we just needed to do something. So I'll see you guys when we see next. If you have any question, please drop it on the group chat or my DM. My number is on the board. So see you guys later. Have a wonderful night rest, everybody. Yeah, thank you very much, Michael. Nice class. Thank you. Um, Calculate. Interesting class. Thank you very much. So guys, once again, thank you, thank you, thank you. Have a wonderful night rest. And God bless you guys. Please pray before you sleep. The Lord is good.